Hello everyone, in this video we're gonna learn how to solve this challenging problem from the math contest. Given 6 cores, each will be numbered differently from a set A equals 1, 2, 3, 4, 6, and 8. We need to draw 3 cores randomly. What is the probability for these 3 cores to form an obtuse triangle? Alright. So first, we need to know the following formula to help solve these problems. The first one is going to be combination. The second one is going to be triangle inequality. The third one, the law of cosine, and the last one, probability formula. Alright. So we need to find the total possible outcomes. We draw 3 cores randomly, and then the order does not matter. So we're going to use combination instead of permutation. Alright, so we're going to pick 3 out of 6. So it could be combination of 6, 3. It's going to be 6 factorial over 3 factorial times 6 minus 3 factorial. Alright, so it could be 6 factorial over 3 factorial times 3 factorial, and it's going to be 6 times 5 times 4 times 3 factorial over 3 factorial times 3 factorial. Now 3 and 3 factorial right here cancel out. Now 3 factorial right here, I just write 3 times 2 times 1. Alright. 4 divided by 2 is going to be 2. 6 divided by 3 is going to be 2. 2 times 2 times 5 is going to be 20 possible outcomes. Alright. Now, let A be the silent of BC. Let B be the silent of AC. And let C be the silent of AB. And then you know that the angle C is the obtuse angle. And then C is the biggest silent. Alright? So, without loss of generality. Suppose A less than B less than C. So we can conclude that C must be greater than or equal to 4. Alright, because the triangle inequality say C must be less than A plus B. Alright, so if C equals 3 and A equals 2 and B equals 1, right? And then when you add this guy up, this guy must be equals. So it does not guarantee that the triangle ABC exists. Alright, so C must be greater than or equal to 4. Alright. Now, if C greater than or equal to 4, and then we have C will be 4, 6, or 8. Alright. Now, next one. In order for the triangle ACB to be an obtuse triangle, alright, we must have cosine C less than 0. Alright, and for less than or equal to C less than A plus B. Alright, now cosine angle C, we're going to use law of cosine right here. It's going to be equivalent to A squared plus B squared minus C squared over 2AB less than 0. And then 4 less than or equal to C less than A plus B. Alright, this guy less than 0, but A is positive, B positive. So we only need a squared plus b squared less than c squared. And then 4 less than equal to c less than a plus b. Alright, we only need the top less than 0. And then I add c squared both sides. I get this one. Alright. Alright, now we're going to take square root both sides. Alright, so we end up with square root of a squared plus b squared less than c. Alright, but we know that c less than a plus b. So we just write this one as a compound inequality. And then c must be 4, 6, or 8. Now we have 3 different cases. The first case, case 1, c equals 4. If c equals 4, and then by triangle inequality, a equals 2 and b equals 3. So we have the first solution, 2, 3, and 4. Now case number 2. C equals 6. We have C equals C less than A plus B. But A less than B. So I just substitute B for A right here. So this guy must be less than 2B. Alright. So I combine 6 and 2B right here. So I have 6 less than 2B. Or B greater than 3. Which means B equals 4. Alright. B equals 4. And then this implies that A equals 3. Alright. A cannot be 1 or 2 because it does not satisfy the triangle inequality right here. Alright. So we have the second solution. It's going to be 3, 4, and 6. Alright. Now let's move on to case number 3. C equals 8. Now again, we have 8 equals C less than A plus B. And then less than 2B. Alright, because I substitute B for A right here. And A less than B, so it can be less than 2B. And then from here, I just rewrite this one as 8 less than 2B. Or B greater than 4. Alright. B greater than 4. Now I don't have enough space. I'm going to write over here. And then this implies that B must be 6. Alright. If B equals 6, and then A equals 3. Or A equals 4. So we have 2 solutions right here. The first one, A equals 3, B equals 6, and C equals 8. Now the second one, A equals 4, B equals 6, and C equals 8. Alright, so we have total 4 solutions. The first one right here. the second one right here, and the third one right here, the fourth one right here. Now we apply the last formula right here, probability. So the probability is going to be equal to 4 divided by total possible outcomes, which is 20. So it's going to be 1/5. And this is the final answer. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand